Testing, can you hear me? Testing, can you hear me? Okay, so I'm going to be studying introductory statistics from Openstax again. I am going to read it from where I last left off, which is hypothesis testing with one sample. This chapter right here, type 1 error, type 2 error. I learned about how to do hypothesis testing. This chapter seems to be about hypothesis testing with two samples. Studies often compare two groups. For example, the researchers are interested in the effect aspirin has in preventing heart attacks. Over the last few years, newspapers and magazines have reported various aspirin studies involving two groups. Typically, one group is given aspirin and the other group is given a placebo. Then the heart attack rate is studied over several years. There are situations that deal with the comparison of two groups. For example, studies compare various diet and exercise programs. Politicians compare the proportion of individuals from different income brackets who might vote for them. Students are interested in whether SAT or GRE preparatory courses really help raise their scores. We have learned to conduct hypothesis tests on single means and single proportions. We'll expand upon that in this chapter. We'll compare two means and two proportions to each other. The general procedure is still the same, just expanded. You compare two means and two proportions. You work with two groups. The groups are classified either as independent or matched pairs. Independent groups consist of two samples that are independent, that is, sample values selected from one population are not related in any way to sample values selected from the other population. Matched pairs consist of two samples that are dependent. The parameter tested using matched pairs is the population mean. Parameters tested using independent groups are either population means or population proportions. The two independent samples are simple random samples from two distinct populations. For the two distinct populations, if the sample sizes are small, the distributions are important. Should be normal. The sample sizes are large, the distributions are not important, need not be normal. The test comparing two independent population means with unknown and possibly unequal population standard deviation is called the Aspen Wedge t-test. Degrees of freedom formula was developed by Aspen Aspen wedge. Comparison of two population means is very common. A difference between the two samples depend on both the means and standard deviation. Very different means can occur by chance if there is a great variation among the individual samples. In order to account for the variation, we take the difference of the sample means x1 minus x2 and divide by the standard error in order to standardize the difference. The result is a t-square test statistic. Because we do not know the population standard deviations, we estimate them using two sample standard deviations from our independent samples. For the hypothesis test, we calculate the estimated standard deviation or standard error or the difference in sample means x1 minus x2. The standard error is s1 square over n1 plus s2 square over n2. The test statistic is calculated as follows. X bar 1 minus x bar 2 and then minus it with the difference in it, mean. Then divided by square root s1 square divided by n1 plus s2 square divided by n2. S1 and S2, the sample standard deviations, are estimates of sigma 1 and sigma 2 respectively. Sigma 1 and sigma 2 are unknown population standard deviations. X bar 1 and X bar 2 are the sample means. Mu 1 and mu 2 are the population means. The number of degrees of freedom requires a somewhat complicated calculation. However, a computer and calculator calculates it easily. The DF are not always a whole number. The test statistic calculated previously is approximated by a student's t distribution with DF as follows. Degrees of freedom is this. So we are using the student's t distribution and we are using the degrees of freedom as this. When both sample sizes N1 and N2 or 5 are larger, the student's t approximation is very good. Notice that the sample variances S1 and S1 squared and S2 squared are not pooled. When the question comes up, do not pool the variances. What do you mean by pool? S1 square, S2 square. The average amount of time boys and girls aged 7 to 11 spend playing sports each day is believed to be the same. Study is done and data are collected resulting in the data in table 10.1. Each population has a normal distribution. Girl sample size, boy sample size 16. Sample standard deviation 0.866. 1. Average number of hours playing sports per day. Is there a difference in the mean amount of time boys and girls aged 7 to 11 play sports each day? Test at a 5% level of significance. Okay. So I need to do the t distribution, right? Um, t distribution, but I need to calculate the degrees of freedom. So the degree of freedom degree of freedom. I have to write this whole equation. Wait, let me do S1, S2, N1, N2. 9, 0.866, 9, 6, equal 1, equal 16. Square. Do I have to write the? I don't even know if this is correct. Square divided by n1 plus s2 square divided by n2. I'll call it d1. 1 square divided by, and then d2 is s2 square divided by n2. D2, D1. Hold on, let me see. One over n1 minus 1. 1 over n2 minus 1. Test at a 5% level of significance. Is there a difference in mean around in the mean amount of time boys and girls aged 7 to 11 pay sports each day? Difference in sample mean amount of time girls and boys play sports each day. I have to do 3.2 minus 2, right? Which will give 1 point. Hold on. 1.2. DF is approximately 18.846 to 18.846. Yeah. The p value is 0.0054. Calculate the p value using students' t distribution. How do they calculate the p value? 18, plug in L. So DF, degrees of freedom. I have to do degrees of freedom minus 1, right? 1.2 and minus 1.2, 0.0054. Um, 1.2. I don't understand. This is the t distribution. Inner, outer, less than minus. I get 2.46. They're getting 0.0054. I don't understand how they calculated this. So I get, okay, I'm using the t distribution. Degrees of freedom, we are already accepted 18.8462. 18.8462. So degrees of freedom minus 117.8462. But it doesn't make a difference. I don't understand. 1.2 is the difference in the mean. Difference in the mean is 1.2. Calculate p-value using students t distribution. It says here 0.246. Um, I'm still thinking how this is possible. Students t distribution p-value 0.0054. A study is done by a community group and two neighboring colleges to determine which one graduates students with more math classes. College A samples 11 graduates. Their average is 4 math classes with a standard deviation of 1.5 math classes. College B samples 9 graduates. Their average is 3.5 math classes with a standard deviation of 1 math class. The community group believes that a student who graduates from college A has taken more math classes on the average. Both populations have a normal distribution. Test at a 1% significance level. Answer the following question. Is this a test of two means or two proportions? Two means, right? Are the population standard deviations known or unknown? For math classes with a standard deviation of 1.5. So it's known. What? Population standard deviations known or unknown? Oh no, these are the sample deviations. Population standard deviation is unknown. What distribution do you use? Sample sizes are small, the distribution are important. Do we use the T distribution? But they say it's normally distributed, right? Both populations have a normal distribution. Yeah, T distribution. What is the random variable? The random variable x bar is the average number of classes students in college A takes. So x bar A minus x bar B. The null hypothesis is this is the alternative hypothesis that A takes more math classes. Null hypothesis is that A doesn't take more math classes. Alternative is that A takes more, the average of A is more than average of B. Is this test left, right, or two-tailed? It's right-tailed, right? Right. What is the p-value? Talking about the t distribution, so xa minus xp, 0.5. 1% significance level. We have to divide it by the standard deviation, right? The p-value is 0.5, right? 0.1928. How? S1 is 1.5. S2 is 1, 11, and 9. 11 and 9. Average is 4 math classes with standard deviation of 1.5. 9 graduates, standard deviation of 1. 10 graduates, standard deviation of 1. I got this, and then I need to check this. I don't understand how they got the p-value of 0.1928. Yeah, using the student's t distribution. 3.5. 4 minus 3.5 is 0.5. Okay, I don't understand how they got 0.1928. Since there's 1% level of significance, we do not reject. Okay, this I understand. But I don't understand how they're getting 0.1928. I need to see. Maybe they can show the calculation how they got from here to here. The test statistic is minus 3.14. 18.8462. 0.0285. P value is 0.0054. P value is the area, right? So if I plug in 0.5, sorry, 1.2, 0.1229, how is this possible? Maybe I'm using the wrong distribution. Cohen's t is a measure of the effect size based on the differences between two means. Cohen's t, named for United States statistician Jacob Cohen, measures the relative strength of the differences between the means of the two populations based on sample data. Calculated value of the effect size is then compared to Cohen's standards of small, medium, and large effect sizes. Small, medium, large, 0.2, 0.5, and 0.8. Cohen's d is a measure of the difference between two means divided by the pooled standard deviation. Calculate Cohen's d for example 10.2. Is the size of the effect small, medium, or large? Explain what the size of effect means for this problem. 10.2 is for which problem? This? Okay. For 1.5, 11, 3.519, 0.384. The effect is small because 0.384 is between Cohen's value of 0.2 and zero point 0.5 for a medium. Size of the differences of the mean for the two colleges is small, indicating that there is not a significant difference between them. Example 10.3, 0.834. Size of the differences between the means of the final exam scores of online students. A face-to-face class is large, indicating a significant difference. Yeah, I need more practice with this. I do not understand how they got the p-value. Use TDF, where DF is calculated using the DF formula. Calculate p-values using the student's t distribution. They put 1.2 over here. They got 1.2 from 3.2 minus 2. I have no clue. Let's see the t distribution chapter. Uh, so what they said is that the degrees of freedom is calculated like this. And then they gave us the thing and we calculated it correctly as 18.8462. Well, this is a different exercise. And let's do this one instead. So we calculated it correctly as do they mention it here? No, they don't. 0.8661. 9 and 16. 0.8661. Hold on. This is 9. This is 1. Yeah, we calculated this correctly. The degrees of freedom. And the T score. TDF, where DF is n minus 1. We don't do minus 1 with this, right? Um, okay, let's just learn about it offering. Even though this situation is not likely, knowing the population standard deviation is not likely. The following example illustrates hypothesis testing for independent means. Known population standard deviations. Sampling distribution for the difference between the means is normal and both population must be normal. In the random variable x1 minus x2, the, the random variable is this. The normal distribution has the following format. x1 minus x2 normally distributed mu1 minus mu2. Okay, the standard deviation is this. This is when the population standard deviation is known, right? The z score is this. Independent groups, population standard deviations known, meeting the mean lasting time of two competing floor waxes is to be compared. 20 floors are randomly assigned to test each wax. Both populations have a normal distributions. The data are recorded in table 10.10. Wax sample mean number of months. Floor wax last. Population standard deviation. Does the data indicate that wax 1 is more effective than wax 2? Test at a 5% level of significance. So I have mu1 minus mu2. Mu1 minus mu2. 3 minus 2.9. Population standard deviation. And floors are randomly assigned to test each wax. Each wax has a n of 10, right? 0.33 square divided by 10. 33 square divided by 10 plus 0.36 square. So this is how it's divided. Does the data indicate that wax 1 is more effective than wax 2? Sample mean 3.3 minus 2.9. That is correct. Wax 1 is more effective than wax 2. Do I have to get the z-score? Like what am I trying to calculate? The mean for the normal distribution is 0. So what is the null hypothesis that both of them are equally good? 3 minus 2.9. 0.259. So no, right? How did they get 0.1? 0. I don't understand. Calculate the p-value using the normal distribution 0.1977. Sorry, 1799. 0.1, yes. 0.1 divided by 20. 1799. Okay. So do not reject the null hypothesis because the alpha is 0.05. This one I understand. I don't understand the one with the t distribution. Think maybe they made a mistake, but yes, someone can chat. Chat can help. When conducting a hypothesis test that compares two independent population proportions, the following characteristics should be present. The two independent samples are simple random samples that are independent. The number of successes is at least 5. The number of failures is at least 5 for each of the samples. Growing literature states that the population must be at least 10 or 20 times the size of the sample. This keeps each population from being oversampled and causing incorrect results. So, okay, we have two independent samples. Number of successes are at least 5. Number of failures is at least 5. Growing literature states growing literature states that the population must be at least 10 or 20 times the size of the sample. Okay, so the population is at least 10 or 20. They should just pick one number. Comparing two proportions, like comparing two means, is common. If two estimated proportions are different, it may be due to a difference in the populations, or it may be due to chance. Hypothesis test can help determine if the difference in the estimated proportions reflects a difference in the population proportions. Like the case of differences in sample means, we construct a sampling distribution for differences in the sample proportions. P apostrophe A is equal to XA over NA. P So proportion B is equal to XB over NB. The sample proportions for the two sets of data in question XA and XB. The difference of two proportions follows an approximate normal distribution. Generally, the null hypothesis states that the two proportions are the same. That is, null hypothesis is PA is equal to PB. Okay, so the null hypothesis is that the proportion of the sample is equal. Conduct the test, we use a pooled proportion PC. Pooled proportion. The distribution for the differences is proportion A minus proportion B is distributed like this. The test statistic Z score is Z is equal to this minus this over this. Two types of medications for hives are being tested to determine if there is a difference in the proportion of adult patient reactions. 20 out of a random sample of 200 adults given medication A still had hives 30 minutes after taking the medication. What is hives? 12 out of another random sample of 200 adults given medication B still had hives 30 minutes after taking the medication. Test at a 1% level of significance. Test what? They just said test. Uh, Determine if there is a difference in the proportions of the adult patient reactions. Determine if there is a difference. So 20 out of a random sample of 200 adults given medication A still had hives 30 minutes after taking the medication. 12 out of another random sample of 200 adults. It's the same 200 adults, right? Given medication B still had hives 30 minutes after taking the medication. Medication A and medication B. So we assume that it's normally distributed. 0 and PC. PC is XA plus XB over NA plus NB. XA and XB, they're 30, right? 30 plus 30 is 60. Divided by 60 divided by 20 plus 12. One over NA 20 plus 1 over 12. The Z score is proportion of A minus PA minus PB. I don't get what the issue is. Error computing the scenario. Is it negative? Yeah, it is. XA plus XB. 20. What is X though? PA minus PB, difference of proportions of adult patients who did not react after 30 minutes to medication A and to medication B. Twenty plus 12 divided by 200 over 200. Okay. So 20 out of the random sample of 200 adults. 20 plus 12 over 200. Okay. So it's 20 plus 12. Oh, I'll just write 400. 400 over 400, 0.08. 1 over 200 plus 1 over 200. P A minus P. P follows an approximate normal distribution. Um, Calculate the P value using the normal distribution. P value is 0. Out of nowhere, they just plug in, give us the P value. Okay, so this follows a normal distribution. How did they get this now? Is it the Z score? But then how did they get this? P and PB are what we are calculating. So is it 20 over 200 minus 12 over 200? Is it that? 20 minus 12 over 200. 0 point. Um, I have no clue where they got the P value from. Okay, I will need to see some example outside. I'll see some example off stream because I'm not able to understand any of the P value stuff. I was able to understand it last chapter, but I don't know why. This chapter I'm not able to get it. When using a hypothesis test for matched or paired samples, the following characteristics should be present. Simple random sampling is used. Sample sizes are often small. Two measurements are drawn from the same pair of individuals or objects. So for the matched pairs or paired sample, differences are calculated from the matched or paired samples. The differences form the sample that is used for the hypothesis test. Either the matched pairs have differences that come from a population that is normal, or the number of differences is sufficiently large so that distribution of the sample mean of differences is approximately normal. A hypothesis test for matched or paired samples, subjects are matched in pairs and differences are calculated. Differences are the data. The population mean for the differences UD is then tested using students' t distribution for a single population mean with n minus 1 degrees of freedom. And n is the number of differences. Test score t score is this. Okay, let's see. College softball coach was interested in whether the college's strength development class increased their players' maximum lift in pounds. Four players participated in the study. The amount of weight they could each lift was recorded before they took the strength development class. After completing the class, the amount of weight they could each lift was once again measured. The data are as follows: amount of weight lifted prior to the class, alright, amount of weight lifted after the class. So the strength development class increased their players' maximum lift. Coach wants to know if the strength development class makes the player stronger on average. I got the difference data. Calculate the differences by subtracting the amount of weight lifted. Or they're just giving us the answer. Wait, let me think. Let me think about this. Shouldn't I be doing this first? Well, I already started that. So, four players and the t distribution is n is the number of differences. T distribution is 3. T score is xt minus ud divided by st over root n. The differences of the sample, right? Sample differences. Okay. I think it's better if I do this. Mean 205 minus 295 90 241 minus 252 33. Wait, hold on. Which one is minus which? This is supposed to be the bigger one, right? So 295 minus 205 is 90. 252 minus 241. 252 minus, is it 9? Yeah, who cares? And then I think this is minus 8. 330 minus this. Minus 8. 360 minus this is minus 8 again. 21.25. 21.25. And then we have standard deviation is 46.7. T square is xt. So the mean the T score. So what do we plug in though? What do we plug in? 21.3 and 46.7. This test, this becomes a test of a single. Uh, where's the answer? Single variable? Single difference variable? We define the mean difference in the maximum lift per player, follows a t value, and then I'm calculating 21.3, right? 21.3. I don't think this is correct. Hypothesis test is t distribution with value 3. Um, so the difference is less than 0 more. But the thing is, why is the graph over here so different? T distribution. Yeah, I understood this, but the thing is, the p value is the final thing that's confusing me. Wait, I will try to find an online t distribution somewhere. Online t distribution calculator. It's called Stat Trek. Yeah, let's see. Degrees of freedom is 3. T score is 21.3. I don't think this is the issue here. Okay, I don't. P value is 0.215. Okay, I do not understand what's going on. Someone can help me, that would be great. The next just seems to be an exercise, but doesn't have an answer. Uh, is the G square related to the previous chapter? I don't think it is. So I will just study this the next stream then. All right, then I will see you guys next time. Bye.